This video continues our discussion of the system of linear equations, and it's going to focus on the addition method, which is sometimes also called the elimination method. It kind of depends upon which textbook you pick up. So it's a lengthy process, but it's algebra based, and you're able to get exact answers as opposed to having to do estimation when you use the graphing method. So here again are the steps which you can read through. Pause the video and read through them. But I want to jump into the examples because sometimes it's easier to see an example than it is to try to read through those steps. What you're trying to do with the addition method or the elimination method is basically add the two equations together, and in the process of adding them together, you want to eliminate one of the variables, and you get to kind of choose which one you eliminate. And to do that, sometimes you may have to multiply one or both of the equations by a number so that you create the opposite coefficient. So if I look at this particular problem, 5x plus 9y equals 16 and x plus 2y equals 4, I notice I don't have the same coefficient in front of the x nor the y, and I also need them to be opposites so that when I add them, they will go to 0. So what I'm going to do is I'm going to multiply the second equation by -5. Since there's a coefficient of 1 here, if I multiply this entire equation by -5, let's see what happens. Okay, the first equation, 5x plus 9y equals 16, is just going to stay the same. The bottom equation we're going to multiply through by -5. So I have -5x minus 10y equals -20. And then I'm going to add those two equations together. That's why it's called the addition method, because you add the two equations together. So 5x minus 5x is 0, and we've eliminated the variable. 9y minus 10y is minus 1y, and that equals 16 plus -20 is -4. Now I have a basic equation with one variable, and I can solve it by dividing both sides by -1. So y equals +4. I'm then going to take y equals 4, and I'm going to substitute it into one of the equations. It doesn't matter which one. I'm going to use the bottom one and figure out the value for y. And I'm going back to the original equation. So I would have x plus 2 times, and in place of y, we've determined that its value is 4, and that's equal to 4. So we have x plus 8 equals 4. And then again, I have kind of a pretty basic equation that I can solve for x. I'm going to subtract 8 from either side. So I have x equals -4. So the ordered pair that's a solution to this problem would be -4, 4. I have a single solution. So remember, when you have a single solution, just as a quick review, it's called an independent system. Okay, now you can double check yourself by plugging in -4 and 4 into both equations, okay, to double check and make sure that you get the value. I'm not going to take the time to do that. All right, next example. 5x minus 2y equals 2.25, and 7x minus 4y equals 3. Now again, you can be selective as to which variable you want to eliminate. In this case, I notice I've got a -2 and a -4 in front of the y. So I think I want to try to eliminate the y's. And if I multiply the top equation by -2, I can transform the value in front of the y to be +4. So that becomes -10x plus 4y equals 2 1/4 times 2, let's see, is 4 1/2. So it's 4.5. And then the bottom equation stays the same. So we have 7x minus 4y equals 3. Then I'm going to add the two equations together. We're basically forcing one of the equations or one of the variables to have opposite coefficients. So -10x plus 7x is -3x. Plus 4y minus 4y goes away. So the y variable is eliminated. And that equals 4.5 plus 3, which is 7.5. I'm then going to solve that basic equation to figure out the value for x. I'm going to divide both sides by -3. So 7.5 divided by 3 gives me a value of x equals -2.5. I then take that value, remember, and I have to substitute it back into one of the given equations. So this time I think I'm going to go back to the first equation. It doesn't matter. You can choose. So I would have 5 times -2.5, substituting in the value that I know, and then continuing with the calculations, minus 2y equals 2.25. So 5 times -2.5 gives me -12.5 minus 2y equals 2.25. Solving for x, I'm going to add 2.25 to either side. Let me change colors for you so you can see what I'm doing. Okay, so plus 12.5 plus 12.5. So we have -2y equals 14.75. Then we're going to divide both sides by -2. So y equals 7.375. Okay. So our answer, our ordered pair that satisfies these two equations would be, what's your order? Remember, do the x first. -2.5, 7.375. And again, you can double check yourself by substituting that answer into both equations and verifying it makes a true statement. Again, because you have a single individual ordered pair, remember this is called an independent system. Okay, it's called an independent system. All right, one more, and this one gets a little bit messier because it starts out with fractions. So quite honestly, the first thing I would want to do is eliminate the fractions from both of the equations. I notice in the first equation, I have a denominator of 12, which is going to give me 12x minus 5y equals -55. The second equation, I notice, has a common denominator of 2, so I'm going to multiply the equation by 2, and I get -12x plus 5y equals 55. Well, when I finished that, I noticed that I have opposite coefficients, the same coefficient that and they're opposites on the x, and actually also the y. So here's what's going to happen. I have 12x minus 5y equals negative 55, and negative 12x plus 5y equals 55. 12 plus negative 12 is 0, minus 5 plus 5 is 0, so I end up with nothing on the left. Negative 55 plus 55 is 0. Notice that there's no variable left, and this is a true statement. Okay, so that tells me that basically any variable or any ordered pair that I can find that makes the equation negative 12x plus 5y equal 55 is going to make it true. So this is what we call a dependent system, and you have an infinite number of solutions. I kind of have a chart here at the end of this video that kind of summarizes for you what can happen visually on the graph as well as algebraically if you're using substitution or the addition method. So this may help you in terms of realizing whether what it should look like and whether you have one solution, no solution, or infinitely many solutions.